All right, on 11, we want to take the same steps that we took on number 10. So what we're going to do is we're just going to take the derivative of this guy and set him equal to 0, and then create a sign chart and find where those values increase and decrease. So the derivative of this is 27 minus 3x squared. And go ahead and set him equal to 0. So negative 3x squared equals negative 27, x squared equals 9, x equals plus or minus 3. Not horrible, not horrible at all. So we're going to look at our two values here, negative 3 and 3 for my sign chart, and I'm going to use my derivative, which is 27 minus 3x squared. So I don't think that's too hard of a guy to use, because we have to use the original. We can't use a reduced form of this. All right. So if I put a number like, say, negative 5 in, some sort of negative 5 thing, and I don't like where he's written negative 5. We'll check negative 5, 0, and 5. So when I put negative 5 in here, that gets me negative 3 times 25. That's a really large number that 27 can't fix. So I'm going to have a negative here. And then I'm going to put 0 in. And when I put 0 in, I have a positive. And then when I put 5 in, I have the same situation, because negative 5 squared is positive. So I end up with a situation like this. And what this tells us is that our graph decreases, increases, and decreases. So what does that tell us? That tells us that we're going to have a minimum value. We're going to have a minimum value when x equals negative 3. We're going to have a maximum value when x equals positive 3. And if we want to know the y values that match that, then what I'm going to do is I'm just going to run up here, and I'm going to go 27 times negative 3 minus negative 3 cubed, and work that out, and I get my matching y value. I can get my y value for the other one, for my maximum, by saying 27 times 3 minus 3 cubed. So if I need that y value, and it's totally fine to find, this is how I would find it. So what's going on when I look for the extreme values on this? I have a minimum at negative 3 and a maximum at positive 3. All right, on question number 12, we want to find all the possible functions with the given derivative. And so they're telling us that f prime of x equals 9x squared plus 18x plus 5. So we've got to go up instead of down, and that can be tricky because we've spent so much time coming down instead of going up. But I know my original function, and not that, but this right here. I know my original function has to have x cubed, because I go up from x squared. I know that my original function has to have an x squared, because I go up from x. And I know that I'm going to add an x to the 5 here. So, and then because I'm going the other way, I always add a c every time. Now, think about yourself. 3 times what gives me 9? 3 times what gives me 9? That's how I take my derivative. And that's going to be 3 times 3. 2 times what gives me 18? Think about it now. 2 times what number gives me 18? That's how I take my derivative. And that's going to be a 9. So my function, and this is kind of spread out, I'll write it a little neater, should be 3x cubed plus 9x squared plus 5x plus c. And that's all there is to it. You just ask yourself, hey, what do I need to do to go up instead of down? What do I multiply by? What do I divide by? What power increases by 1 from what I'm given? Those are the questions that you're going to ask yourself. And we're going to spend a whole second semester talking about what we just did. But right now, we're just trying to discover it and see why it works. All right, we have the same situation going on here that we had on our previous example. So we are given the function, the derivative of the function. We need to find, what the function is. What's going on here? So 4x, and we got this 4 in the front. Like, does he stay? Does he go? I don't know. I'm not going to write him down just yet. So I'm going to go ahead, and I know that the derivative of what is cosine? The derivative of what is cosine? And that's going to be sine. Okay, the derivative of the sine is cosine. I'm also going to go ahead and leave that 4x in there. If you've got 4x in the middle of a trig function, he has to stay in the middle of a trig function. I'm also going to add a plus c out here because you can't have an antiderivative without the good old-fashioned plus c. Now, what about that 4 in the front? Well, here's the deal. That 4 in the front of my derivative happens because of the chain rule. So if you look at what we just wrote down, sine 4x plus c, and we take derivative, the derivative of the sine of 4x is cosine 4x times the derivative of 4x. It's chain rule. I'll work it out over here on the side so you can check it out. The derivative of c, which is a constant, will be 0. So when I look at sine 4x, if I just look at sine 4x, the derivative of this is going to be cosine 4x times the derivative inside here, which is just 4. And hey, that's the derivative that we were given. So again, you got to ask yourself, what has to happen? What do I need to multiply by? What do I need to take the derivative of to get sine or cosine or secant squared or whatever? And then you work backwards from that. All right, now let's look at 14. It's the same as what we've been doing on these previous two problems, but it's different, okay? They say, hey, I want to find a function whose derivative is x minus 4. Oh, by the way, I want the 0.19 to be on that function. And so I got a little clip happy here. This is not supposed to be there. There we go. That looks better. And so what I'm going to do is I'm just going to go, okay, I've got x. This has got to go to x squared. Has to go x squared. The minus 4 has to go minus 4x. I have to have plus c. Now, the thing is, how do I go from x squared to just x? Like, what do I have to multiply by? 2 times what is 1? Okay, 2 times what number is 1? Turns out it's 2 times a half. So my original function is 1/2 x squared minus 4x plus c. Now, here come the rules. They give us an x and a y. And for whatever reason, sometimes the teenage brain doesn't recognize that when you're given a point, you're given a value for x and a value for y. Like, you can plug in those values into your function for those things. So what have I got? I've got 9 equals 1/2 times 1 squared minus 4 times 1 plus c. Now, the only variable I have left is this c, and so what can happen is I'm going to get a specific function whose derivative is going to be x minus 4. So I'm just going to solve this out for c now. It's the only variable that I have left. So 9 equals 1/2 minus 4 plus c. I don't know why I did this. I just went ahead and added 4 to both sides. And then I subtracted a half. I don't know why I worked it out that way, but I did. And so I got 12.5, 12.5. You can write a decimal if you want. If you really want to have a fraction, you could just write 25 over 2. That's going to be the same thing. And then you just write your function now. What is the function? What is the answer? What is the solution that we're looking for? Well, we're looking for this guy right here. F of x equals 1/2 x squared minus 4x plus 12.5. How about that? Pretty cool stuff. All right, check out this guy. This is where we start now connecting all the different graphs of f and f prime and f double prime, okay? I don't think f double prime shows up on this one, but we do need to understand what's going on. If we find derivative, everywhere that derivative is positive, our graph has a positive slope. Everywhere that our derivative is negative, our graph has a negative slope. In other words, when derivative is positive, the graph is increasing. When derivative is negative, the graph is decreasing, okay? Anytime that derivative is equal to 0, you have a max or a min. An absolute value, okay? You have a curve on your graph that's a peak or a valley. So we've been told that we have a continuous and differentiable function. We're told that the derivative is positive from -3 to 1 and from 2 to infinity. Okay, that's important. That means that our graph is increasing. Okay, we're told that the derivative is negative from -infinity to -3 and from -1 to 2. That means that our graph is decreasing. And we're told that f of -3, f of -1, and f of 2, all primes there, they're all zeros. So basically, I've got three peaks and valleys. And let's see then if I can't make some sense of this. So let's go ahead and put out a sign chart here. I know that I've got -3, I know that I've got -1, and I know that I've got 2. Now, I don't know what my original function looks like, but I do know what's going on here. Between -3 and -1, my derivative is positive. I know that from 2 to infinity, my derivative is positive. I know from 0, that from -infinity to 3, I'm negative, and from -1 to 2, I'm negative. So here's a sign chart that kind of shows what's going on. Now, why did I draw the sign chart? So I can see what's going on. That's a bad color, bad color. I can see, let me choose green, teal, what's going on. I'm decreasing, increasing, decreasing, increasing. Guess what? I've got a minimum right here, I've got a maximum right here, and I've got a minimum right here. Now, do I know those exact values? I don't know, but I know where they happen. So, you know, at -3, I've got a minimum value. So I'm going to go ahead and go with right here. And this is an example of a possible graph, okay? I know that at -1, I've got a maximum value, so I'm going to do something like this. And I know that at 2, I've got another minimum value, so I can do something like this. So my graph decreases to -3, so it does something like this. It increases to 1, -1, so something like that. It decreases to 2. Oops, that bump is in the wrong spot, but you get the drift. My artistic abilities right now are shaky at best. And then I increase at the end. So my graph could look like this. It should resemble this. Is this an exact graph? I don't know. I'd need more information. But my graph should look something like this, where I've got these peaks and valleys at -3, -1, and 2. And I should be increasing on both ends. Okay? So there you go, using some information to find the graph.